All right, we're going to talk about high school geometry. Now, if that word just gave you flashbacks to, dusty textbooks and endless proofs about triangles, you're going to want to stick around. We are about to tear down what modern geometry class is really all about.
So let's just get right into it. Is geometry just some abstract logic puzzle? Another box you have to check before you can move on to the more interesting math? For a long time, yeah, that was pretty much the vibe. But the way it's taught today, it's completely different, and it's aiming for something so much bigger.
Because, let's be real, geometry isn't just stuck in a classroom, it is everywhere. And the stuff you see here, these aren't just made-up examples. What's wild is that they're pulled directly from the national standards. We're talking about the actual skills you need to render video games, to design clothes, or even build a house. This is geometry as a practical, hands-on tool for messing with the world around us.
Okay, so how did this big shift even happen? Well, it wasn't an accident. There's a very deliberate plan, a blueprint behind this whole new approach. So let's pull back the curtain and look at the big ideas that are completely reshaping the subject. And that blueprint is the Common Core State Standards for Math. Think of this document as the master plan. It doesn't just lay out what kids should learn, but it sets up the whole philosophy for how to teach it. It's the why that drives all the what.
And this right here, this is the absolute heart of the new approach. Instead of just staring at static shapes on a page, modern geometry starts with movement. The huge idea is that we can understand if two shapes are identical, or congruent, by seeing if we can slide, turn, or flip one to land perfectly on top of the other. These moves, the slides, turns, and flips, are called rigid motions.
So the crucial thing to see here is that this new way of thinking weaves a bunch of big ideas together. First, like we just saw, it's all about understanding shapes through transformations. Second, it brilliantly connects algebra and geometry using coordinates on a graph. Third, don't worry, proofs aren't gone. It still hammers home the importance of building a careful, logical argument. And finally, it's constantly pushing students to take these ideas and apply them to real-world situations.
But how does a big, fancy idea from a national document actually end up in a real classroom? Well, it's actually a pretty straight line. It flows from a national framework like the Common Core you see on the left, right down to the specific curriculum of a school district like Fort Bend ISD over on the right.
And this is where the rubber really meets the road. We're going to take a quick tour through a typical year in a geometry class to see how those huge philosophical ideas actually get broken down into day-to-day lessons.
So get this, the year doesn't even kick off with shapes and formulas. Nope, it starts with learning how to think. The very first unit is all about building the tools for logical reasoning, and that becomes the bedrock for everything else that comes later. And check this out. One of the very first skills a student has to master isn't just proving things true, it's proving them false. Right from day one, the goal is critical thinking. If someone makes a claim, can you find that one single example that totally breaks their argument? That is an incredibly powerful skill.
All right, let's jump forward a bit to Unit 4. And hey, look, it's our old friends, the triangles. But notice the name here. It's not just triangles, it's proofs of triangle congruence. The whole focus is on the how and the why.
And there it is again, that big idea. To prove two triangles are the same, students have to circle back to that core concept of rigid motions. Can you slide it, rotate it, or flip it to land exactly on the other one? It turns the proof from a boring checklist into a dynamic, active process.
Okay, let's look at just one more example to see how things progress. By the time we get to Unit 7, we're talking about circles, but again, the theme is the same. It's all about discovering relationships and then being able to prove them logically.
This is just a perfect, concrete example of what's expected. A student has to take a bunch of different ideas, tangent lines, a radius, a right angle, and weave them together to build a logical proof. It's all about connecting the dots.
So we've seen what students are learning, but the how they learn it is just as revolutionary. The way teachers actually teach this stuff has gone through a massive overhaul to support these new goals.
Look, the whole point here is to get way beyond what we used to call plug-and-chug math, where you just memorize a formula and jam the numbers in. The real goal is for students to genuinely get why the formula works, so they can use that idea in situations they've never seen before.
And this is the main tool in the toolbox for building that kind of deep understanding. It's called the Concrete Representational Abstract Model, or CRA for short. and it's a super intentional pathway to lead a student from hands-on stuff all the way to symbolic math.
Okay, let's break this down real quick. It all starts with concrete. Students are physically touching things, moving blocks around, getting a real feel for an idea. Then they move to representational, where they learn to translate that physical experience into drawings and diagrams. And only then, after they've got that solid foundation, do they move to the abstract, the X's and Y's and formulas. This makes sure that those symbols are actually attached to real meaning.
So we've looked at the big ideas, the classroom, the teaching methods. Now let's just zoom all the way out one last time and ask, what is the end game here? What's the ultimate point of all this? Because, at the end of the day, it's not really about whether you remember some random theorem about a pentagon 10 years from now. It's about the mental muscles that you build getting there. The real objective is to develop a very specific kind of thinking, precise, logical, and creative. And this quote right here, this is the whole game. This is the absolute core of it all. Can you build a solid argument that's based on evidence? And maybe even more importantly, can you listen to somebody else's argument and poke holes in it, find its strengths and weaknesses? That skill is priceless, whether you're in a science lab, a courtroom, or a board meeting.
So, if you walk away with anything from this, let it be this. Modern geometry is about motion and relationships, not just boring static shapes. The real focus is on training your brain for reasoning and problem solving. And it's all about building skills for your actual life, not just for cramming for the next test. Ultimately, this isn't just a geometry class anymore. It's a logic class, it's a problem-solving class, it's a critical thinking class, it's just cleverly disguised with triangles and circles. It's about building a mind that's ready to analyze, to argue, and to create the world around us.
Which really just leaves us with one final thought to chew on. If these are the fundamental rules that govern all the shapes and spaces around us, from our phones to our skyscrapers, what does it really mean to understand them? How do the rules of geometry end up shaping the very world we decide to build?